let's get started. So I'd like to start by stating a fact. Everyone in this room is a genius. Yeah, I can prove that. So Sheldon already knows about it. For those who are still convinced, I can theoretically prove that. So as you know, this session is about best practices. What are best practices? Generally speaking, in a broad sense, best practices are nothing but learning from others' mistakes or experiences. So as per this famous quote, which says that learning from your own mistakes makes you smart, but learning from others' mistakes makes you genius. So today, here you have come here to attend a session on best practices, which implies that you all have come to learn from others' mistakes. That makes each one of you a genius over here. So today's session about virtual port channel best practices and designs on NXOS, or VPC best practices and designs on NXOS. It's more about sharing of experiences, good experiences, not so good experiences, and how these not so good experiences were transformed to great experiences. So let me introduce myself. I'm Nazim Khan. I'm a technical marketing engineer with the data center group. I've been working on the Nexus product line for the last 5 years. So initial part of the 5 years was behind the scene, ensuring quality for NXOS. And in the present role as a technical marketing engineer, I look at some design reviews, some new features, can get into some support issues also. I hold a dual CCI in data center service provider. So before we get really started, can we have a show of hands on how many of you have deployed VPC or worked on VPC? Amazing. It looks like majority of you have worked on VPC at some point of time. The goal of today's session is not to go into the details of the concepts and terminology of VPC, rather than concentrate on the best practices associated with the configurations and designs. We'll also see how the newer technologies like VXLAN, ACI, Fabric Path leverage VPC and how VPC works in conjunction with these technologies. And so the ultimate goal of this session is to get VPC right. So getting it right at the very first time. So if you haven't deployed, or if you're deploying a new system, and if you follow these steps, I hope you'll not have any issues if you follow these best practices. So I can talk about these technologies for days, specifically VPC and the associated technologies, but have got only 2 hours. So I'll not be able to cover the details of the technology like VXLAN, ACI, Fabric Path. There are some related sessions for these technologies, which you are encouraged to attend. And I know FEX or Nexus 2000 will be only covered from a VPC perspective. I'm open to take questions throughout the sessions, but since we have a limited time, as I mentioned, so I may give some short answers to some questions or may defer some questions towards the end. You can use the question manager if you have some specific queries. And if you still have some specific queries, which works out best is you come here after the session and we can have a one-to-one discussion on the same. Apart from that, you can use Meet the Engineer program and schedule a session with me. I'm available for the entire duration of CiscoLive. So how will be so these are the related sessions which you are encouraged to attend. You can pick and choose as per your areas of interest. So how will be the structures of today's session? We start with the VPC feature overview. Herein we discuss the concepts and terminology. Then we look at some configuration best practices. We'll see what is the tried and tested way of building a VPC domain, some configuration specific guidance. Then we look at some design practice, what are the limitations for a particular design and how we can work around those limitations. Then in the next section we talk about the operations update. We see some newly introduced features like self-isolation, graceful insertion and removal. And finally, towards the end, we see how the newer technologies leverage VPC, how VPC works in conjunction with the newer technologies. And finally, we see some related links to get the scale numbers and some reference materials. So let's start by looking at the data center technology evaluation. So we started in the year 2008 and we started using the traditional spanning tree protocol, which was quickly followed by VPC technology 2009. So VPC technology was introduced and there was a whole change to look at how we can block redundant links and avoid spanning tree, because spanning tree is there in the layer 2 networks for a long time. And so VPC was a revolutionary technology. Which then we introduced FEX, fabric path, the standard-based VXLAN, and more recently the ACI, which is a policy-based approach. Talking about it, as I mentioned earlier, VPC was introduced in the year 2009. Why it is still relevant? We are year 2015. Why it is still relevant? Normally, a technology has some span of some 2-3 years. But even though like we have seen like 7 years, and why VPC is still relevant? Sorry? Okay, that's one of it. Like the reason is, VPC is the foundation of all data center technologies. So you can build a seamless layer 2 network fabric or data center fabric using all these newer technologies like fabric path, VXLAN, ACI. But what can we do if you have some legacy switches, some servers which they don't talk these languages, they don't talk ACI, they don't talk fabric path? How do you do it? You can do it with STP, but STP again, one of the links will be blocked. So the best option is to go with VPC. So it's a very popular feature. Almost like 95% of Nexus customers are using it. So when it was introduced, the significance was more over the aggregation access layer. But lately, it has been more towards the access layer with the advent of the newer technologies. Okay. Let's start with the first topic of the day, which is feature overview. We discussed the concepts and the benefits of VPC. We'll do it really fast because I know this has been repeated many number of times, and majority of you have worked on VPC, so this should be okay. So in a normal traditional HTTP layer 2 topology, something like shown here, there is a high probability of forming layer 2 loops. So in order to avoid those loops, what we do is we run spanning tree protocol. What does spanning protocol do? It will block one of those links, simple as it is. So half of your links have been lost to spanning tree protocols. But with VPC, what we do is we form a port channel with the redundant links. How this is done is by tying the two switches, in this case the switches S1 and N2, in something called as a VPC domain. So what essentially it does is, what VPC does is, the two switches in the VPC domain are represented as a single switch. From the switch, like from the access switch perspective, in this case switch S3's perspective, we can see that it thinks that it is talking to only one of the switch. So the benefits are obvious. There are no block ports. All available bandwidth is utilized. Convergence in VPC is in a matter of milliseconds, if not zero. So if you talk about STP convergence, it can be anywhere between 6 to 30 seconds. So let's look at what are the various constraints of VPC. So VPC domain is the domain where the VPC switches live in. So a VPC domain can have 2 switches and only 2 switches. So a VPC domain is essentially composed of 2 switches. The next component, the next terminology we talk about is the VPC peer. So the other switch in the VPC domain is the VPC peer. So from switch S1's perspective, the VPC peer is S2 and vice versa. Then the most important component or the constraint on VPC is the peer link. So the peer link is the heart of the VPC domain. In this, we run a protocol called CFS, Cisco Fabric Services, since the 2 switches have to look like or act like a single switch. So their control planes have to be synchronized. They have to present themselves with a single control plane. This is done via CFS. So all your ARP entries, MAC tables, and we'll talk about a configuration consistency check is done by CFS. So in a good design network, there's always a third leg. So in our case, we have the VPC keep alive link. The VPC is the actual port channel which is going from the access device to the VPC domain. And the definition of VPC member port is simple. Any port on the VPC domain, like the port on which the VPC connects to the VPC domain, is called as a VPC member port. So essentially, we always recommend 2 dual attached devices to the VPC domain. But if some devices which are not capable to do a port channel, and you have to attach it singly or because of some other reasons, it is known as an orphan device. And the port on which the orphan device is connected is called as an orphan port. So let's look, so these are the typical failure scenarios. I've just kept it for reference. So just quickly go through it. If the peer link fails, the VPC secondary. So in a VPC domain, the 2 switches, one will be the master and one will be the safe. So one we call it as a VPC primary and the other is a VPC secondary. So if the peer link fails, the VPC secondary will shut all its VPC legs. This is the other failure scenario wherein if my keep alive fails and the peer link fails, which it can, in that particular sequence, which can lead to a dual brain, wherein both VPC switches take over the role of primary, operational primary. So let's look at the heart of the presentation, the configuration best practices, what is the tried and tested way of building a VPC domain, how the configuration can be tweaked to get the maximum out of the technology. Let's start by looking at building a VPC domain. So the first step in building a VPC domain is to establish the VPC domain ID, define the domain. So you pick any number from 1 to 1000, put the same number. So the same number has to be put across both the switches. The second step would be to establish the keep alive connectivity. We'll talk about what are the options of having the keep alive connectivity. Finally, once the keep alive is up, the third step would be to establish the peer link. And finally, lastly, you create the actual port channel VPC and make sure the configurations are consistent. So you may ask that if I don't follow this particular order, I may still be able to establish VPC. But if you follow this order, you'll be sure that your VPC will come at the very first time. So the order is very important in establishing a VPC domain. So VPC domain ID. So as I mentioned earlier, VPC domain ID is something which ties the switches S1 and S2 to look like or act like a single switch. Now we'll see how it is done. So VPC domain ID is any number you pick up from 1 to 1000, and there is something called as VPC system MAC. It is a reserved MAC for VPC. So if you see it there, the last octet, which is 14 is nothing but the configured value 20 in hex. So both the switches will represent themselves with the VPC system MAC. So both the switches will represent themselves in the layer 2 network with the same system MAC. And it becomes very essential because of this, since they are representing themselves depending on the domain ID. So if you have a contiguous L2 network and you have multiple domains, we'll talk about the DCI case later, but in this case also where you have a back-to-back VPC connected, it is essential to have different domain IDs. The reason is very obvious. If you have the same domain IDs, both the VPC domains will advertise themselves with the same MAC, and you can imagine what issues it can run into when you have the same network, same MAC in the contiguous L2 domain. So let's come to the most important link in the VPC domain, which is the peer link. The main requirement, or it is very essential to have the peer link as a point-to-point link. So there are queries from the field asking that I have a layer 2 infrastructure in place. Can I have my peer link over the layer 2 infrastructure? The answer is no. The reason lies because if there is some problem in the layer 2 infrastructure and there is both the peers lose connectivity, there will not be a mechanism to know whether the other peer has died down or there is some problem in the layer 2 infrastructure. So it is essential, it is mandatory to have the peer link as a point-to-point link. One more query which often comes is, can we use pseudo wires? Again, it is not recommended, as you are running control plane traffic to synchronize the control planes. So the control planes have to look similar. Then again, this also frequently comes up. So we are here to share the experiences. So this also comes up saying that, you know what, you told me we should have 10 gigi links for building the peer link. In my box, I have only 40 gigi or 100 gigi links. Can I form a peer link? So the requirement is at least 10 gigi. You can have peer link formed from 40 gigi ports as well as 100 gigi ports. One more interesting thing comes up is designing of the bandwidth of the peer link. So the common query is, anyways, peer link is not used to carry data traffic. What I'll do is my data traffic is carried by the VPC legs. So I'll build my VPC legs with 40 gigi or 100 gigi ports. And never mind, my peer link is not carrying any data traffic, so I'll make it out of 10 gigi interfaces. Operationally, it will work fine. There's no issue with it. But what happens in a failure scenario? If one of the VPC leg fails, then your peer link will be used to carry data traffic as well as control traffic. Your VPC leg is a 40 gig ports, or total it has an aggregate bandwidth of 80 gig, assuming there are two 40 gig ports. So the peer link, which is formed from 10 gigi ports, will not be matched for the 80 gigi traffic which you are sending. And if you have a large number of orphan ports, in that case also the peer link carries data traffic. So depending upon all these considerations, the number of orphan ports you have in your network, the failure scenarios, the failure risk which you can take, with that taking into account, you have to design the peer link bandwidth. And the system takes care that all ports, all VLANs on the peer link are not blocking, are always forwarding. Okay. Moving to the next constituent, peer keep alive link. So we have different recommendations for the peer keep alive link. For the modular kind of chassis, the systems with dual soup, like the Nexus 9500 series, Nexus 7000 series, the requirement is the first preference is to have a dedicated link. The second preference is to use the management zero interface, and the third preference is the L3 infrastructure. For the fixed kind of series, which is like Nexus 5000 series, the Nexus 9300 series, 3000 series, the requirement, the first preference is to use the management port. Then the next preference in that order is to use the physical links, and finally it is the layer 3 infrastructure. You may ask me why there is a difference between the modular switches and the fixed series of switches. The reason is typically modular switches will have two SOUPs, dual SOUPs, and will have two management ports. So the active, the SOUP which is active will have its management ports as active, and the standby SOUP will have the management port as standby. So in case of a SOUP switchover, you will lose the peer keep alive connectivity. So the first preference is to have a front panel port or the dedicated link between the two switches. This is described in this slide, it's for reference. So spanning tree. So with VPC, we are not eliminating spanning tree. We are just avoiding spanning tree by forming a port channel. Spanning tree is still running as a fail-safe mechanism. So if, and all the operation of spanning tree is controlled by the VPC primary. So all your BPD processing, everything is controlled by your VPC primary. So essentially VPC primary is acting like the STP route, even though if the STP route is configured somewhere else. So we recommend to tie the STP route to the VPC primary switch. And obviously, like as I mentioned, spanning tree is running as a fail-safe mechanism. So we need not disable spanning tree for any of the VLANs in a VPC domain. So peer gateway. So peer gateway is a functionality which was added because some servers, some NAS servers, were not working in a standard fashion. So if, for example, in this case, if you see switch S3, it can send a packet. So if it can send a packet towards switch S1, and because of port channel hash, the packet can get hashed to the switch S2. For example, if the packet has to be routed from the switch S1, if you don't have the peer gateway, in that case, what will happen is the packet will traverse peer link, and from there, if it lands on switch S2, the packet has to traverse the peer link to S1, and from S1 it has to be routed. But when you have the peer gateway configured, the switch, suppose if it is intended for switch S1, the routed MAC is of switch S1, but it lands on switch S2 because of 4 channel hash, the switch S2 will route on behalf of the switch S1. So the issue, the NAS servers were not behaving, the issue was the NAS servers were not forwarding, not doing an ARP to get the gateway IP. They were just sending traffic from the switch which they have received it. So peer switch. So as I mentioned earlier, all my STP in a VPC domain is controlled by the VPC primary. So all the BPU processing generation is being done by the VPC primary. If a BPDU lands on the VPC secondary, it is simply proxied over the peer link to the VPC primary. So when you configure the peer switch, what does peer switch do is make the two switches appear as a single STP route. So the advantages are you need not tie, so we suggest having a best practices of tying the STP route to the VPC primary. So you may not tie the VPC primary, so because both the VPC primary and secondary appear as a single route. The other important thing to note is without peer switch, what happens is when the VPC primary, which is the STP route, reloads. So once it reloads, the VPC secondary will take over the role of STP route. At that time, there won't be any STP changes as such. But when your VPC primary comes back again, since it is configured as a STP route, it will take over as an STP route. So what will happen at that time is there will be an RSTP sync, and there could be an STP reconvergence, and your traffic will be impacted. So it is always a best practice to have the VPC peer switch configured. So as I mentioned about the peer switch, it makes the two switches appear like a single HTTP route. The configuration is simple. Under the VPC domain, it's simply peer switch. So lately, there has been lots of ask about private VLANs. Do we support private VLANs over VPC? What all is supported for private VLANs? So we support isolated trunk, promiscuous trunk, we support promiscuous ports, and any port mismatch is classified as a type 1 consistency. So if I have different ports across the VPC peers, then it is classified as a type 1 consistency. And if there is a configuration mismatch, like the primary and secondary VLANs are mismatched, that is classified as a type 2 consistency check. So a typical example of a type 1 consistency. So in the third diagram, with the type 1 consistency is failing, I have a isolated trunk at one end and the normal trunk at the other end. So the requirement is to have similar port types. And the type 2 consistency check, wherein I do have all the ports same across both the switches, but in the one which type 2 consistency is failing, one with the cross, there is a mismatch primary and secondary relationship. Okay. So let's talk about a very important feature, which is VPC auto recovery. So in a normal scenario, when everything is going fine, traffic is flowing, everything is fine, my traffic is being forwarded through both the VPC peers. What happens when the peer link fails? As soon as the peer link fails and the keep alive link is active, my VPC secondary will think, okay, my VPC primary is doing the job. Let me go and shut all my VPCs in order to avoid any layer 2 loops. Traffic is not being affected at this point. Everything is working fine. No issues as such. But it's one of the days when everything goes haywire. And unfortunately, the VPC primary fails. VPC primary has failed because of hardware malfunction. VPC secondary is up and running fine, there is no problem with it, but it's only suspended its VLAN in order to avoid loops. And at this point, if you don't have auto recovery configured, there is a complete traffic black hole. And to recover from this situation, you need a manual intervention, like you have to shut some ports and get the traffic back again, change the roles. But this can be avoided if you have something called as auto recovery. With auto recovery, what happens is, it will wait for a period of 3 keep alive timeouts. And once it does not hear anything from the VPC peer, it will assume that the VPC primary has died down. It will take the role as a VPC operational primary, bring out all its VPC port out of suspension and start forwarding traffic. So VPC auto recovery is significant in 2 cases, wherein one case which I explained, and the other cases wherein both the VPC peers have reloaded and only one has come back. So let's talk about object tracking. Some months back, there was a case from a European financial customer. Yes, please, you have a question? The question is, I believe, you don't want to configure auto recovery? In a case wherein if you just want to avoid a split brain scenario, because it can happen, the disadvantage of having VPC auto recovery is you can get into a scenario wherein both the peers would be active. So that particular case, I can think about auto recovery is not required. Both come up at the same time and both have assumed the role of a primary. So that is the drawback of using VPC auto. Okay. So object tracking. So as I mentioned, like it was a major financial customer in Europe had a network outage, and they presented to us the design and the sequence of event, what exactly happened. And looking at the case notes, I just asked the question, why haven't they enabled object tracking? Yes, if they would have enabled that VPC object tracking, the situation, the network outage would have been avoided. Let's look at what was the issue they ran into and how object tracking could have helped to avoid that issue. So what happened is, because of some hardware problem, all the modules which were hosting the peer link and the uplink failed. Because of which, what happens is, since the peer link has failed, my S2 will suspend all the VPCs. My VP, yes, please. So in this case, if the peer link goes down, the modules have failed. So my peer keep alive is through the management interface. That has not gone down because the management interface is the burn-in port, and the keep alive is still up. If the keep alive goes down, and if the peer link goes down first and the keep alive goes down first, in that case, it will assume the role of primary. So the question is, it's a good question. So the question is, what happens if my switch as such reloads, like my keep alive also goes down? So in that case, the switch S2, so if one of the VPC peer simply reloads, then the other peer, the VPC secondary, will assume the role of VPC primary and start forwarding traffic. That's not the case over here. The case over here is all the modules have failed, and since my peer keep alive is hosted through the management interface is still up and the peer keep alive is still up. So the secondary really does not know what is happening with the VPC primary at that end. Okay. So at this point, the secondary has suspended all its VPCs. It is working fine. The peer link has died down. VPC primary, there are no modules up and running to forward traffic. And the result is a complete traffic black hole. Auto recovery does not kick in because my peer keep alive is still up. Now, how this issue could have been avoided? So I believe most of you would have used object tracking with first hop routing protocols like HSRP, VRRP. It is the same concept. What we do is we track the peer link, the uplinks, into a Boolean or kind of a list. And if all the links goes down in that, whatever the links we have tracked, in that case, the track object will kick in. And the secondary, so the VPC primary device will just resign from being VPC primary. The secondary will take over the role of VPC operational primary, and it will start forwarding traffic. Okay. So with this, we wrap up the configuration best practices section. In this section, just to summarize, in this section we saw what is the best way of building a VPC domain, what are the best practices what are the best practices associated with various VPC constituents. We saw that how we can optimize. STP is still running as a fail-safe mechanism, and how we can optimize STP by using peer switch. And finally, towards the end, we see some features which, when enabled, features like auto recovery and object tracking, which when enabled can help improve the overall network resiliency and efficiency. So let's move ahead with the next section, which is the VPC design practices. In this section, we'll see what are the hardware, what is the ideal hardware to build a VPC domain, what are the limitations in using different hardwares. We'll also see how the dynamic routing in VPC, what works and what does not work, and what will work in the coming releases. So let's get started with the hardwares. So now this is the most asked question. Can I build a port channel with different line cards on the Nexus 7000 or 7700 series? Can I have F2E card on one end and F3 card at one end? You can't build a port channel with different line cards. The reason is very simple. Form a port channel, the hardware capabilities should match. And if you're using different line cards, the hardware does not match. So if you have different line cards, you can't form a port channel. That means you can't form a peer link. You can't form a VPC. So the thumb rule is to always use identical line cards when it comes to the Nexus 7000 series of switches. And there was a couple of questions from the field, like they wanted to migrate from F2 cards to F3 cards in a VPC domain, and they wanted to have a port channel between F2 and F3 for a limited period of time, for a short period of time, like migration, till the time they are doing some migration. But they just tried doing it, but the software ensures that you don't form port channel between two different line cards. So we don't support it even for a short period of time, like migration. Good news is that on the Nexus 9500 series switches, the line cards with similar hardware capabilities. So the line cards with the similar ASICs, we support forming a port channel. So these are the combinations which we support when forming a port channel on the 9500 series of switches. Now coming to the topic of VPC between different hardwares, like Nexus 7000 on one side, Nexus 7700 on the other side, can I form a VPC peer? So we do support VPC between Nexus 7000 and 7700 for a short period like migration. So it is just a finite period for which we support VPC between 7000 and 7700. But you ask me if I can have a VPC between a 5600 switch and a 5500 switch, that is not supported. That is not supported for migration also. Yes, please, you have a question?
When you say finite timeline, what is that amount of time? It's not just saying so.
Something like a migration or maintenance window.
Yeah, correct. But all features are fully functional?
Sorry, I didn't.
Everything in it is fully functional?
Yes, functional and supported. Okay. So the question is, how do you define the finite time? What is the time limit? It's typically a maintenance window. So one box you have upgraded in one maintenance window, and then you come in and upgrade the other box in the other maintenance window. So, okay. So coming back of forming a VPC between 5600 or 5500, or matter of fact, Nexus 3100 and 3500, we don't support that. The reason is same. The hardware capabilities when forming the port channel should match. Essentially, the ASIC on the hardware should match to form a port channel. The other most common query which comes up is, I have an Nexus 7000 with SOUP 1 on one side and SOUP 2 or SOUP 2E on the other VPC peer. Do we support a VPC on that? Again, it is supported because VPC has nothing to do with the soup capabilities, but as a best practice, it is essential to have the similar soup for deterministic performance across the VPC peers. So FHRP, the first hop routing protocol, which is HSRP, GLBP, VRRP. So we support all these protocols over VPC. We not only support them, we support an enhanced version of that. So by saying an enhanced version, it implies that both of them will be active at the same time. So suppose, for example, in a traditional network, wherein you don't have a VPC and you have a simple spanning tree running and you have HSRP active on one switch and HSRP standby on the other switch. So in that case, what happens is your HSRP is doing all the routing functionalities, all the forwarding functionalities. The standby is just sitting there waiting for active to fail so that it can take over as active and start forwarding traffic. So imagine the same scenario if it happens in the case of VPC. In this example, if you say switch S1 is active and switch S2 is standby, and my packet, because of port channel hash, can land on any of the switches. Suppose if it lands on the switch S1 which is active, it gets forwarded, there is no issue in that. But what if the packet lands on the switch S2, which is a standby, and we have not enhanced the functioning of the protocol. So it will send the packet over the peer link to the VPC primary switch. Once the packet traverses the peer link, the VPC loop avoidance kicks in, and then the packet may be dropped. So what we do from a FHRP perspective, from a HSRP, VRRP, and GLB perspective, even though in this case, if the packet has landed on switch S2, which is operationally the HSRP standby. So the operational states will be the same. One will be HSRP active and one will be HSRP standby. But functionally, the HSRP standby need not send the packet over to the HSRP active. It may directly route it or forward it depending upon the configuration. So since HSRP, the FHRP works in an active-active mode, so aggressive timers are not required, the default timers are sufficient. So the best practice is to have the default timers. Yes, please. Yeah, the functioning of the protocol is exactly same. So the question is, can I have different priorities, like which is the HSRP and standby. So the role function, the operational wise, one will be the HSRP active and one will be the HSRP standby. So you can actually give the preference on which one is it, but the forwarding can happen across both the switches. Another concept in VPC is the backup routing path. So you may have heard that we don't support dynamic routing or layer 3 or VPC, which we'll talk about in detail later in this section. So what we don't support is forming route adjacencies between the switch S5 and S1 and S2 as is in this topology. But what we support is having routing adjacencies between the VPC peers S1 and S2. For example, if you take this case, I don't have any routing adjacencies between the switch S1 and S2. And traffic is getting forwarded irrespective of where it goes, S1 and S2. But imagine a scenario wherein the uplinks fail. Now the switch S2 does not have any routes to the core. So what we recommend here is to have peering between the two VPC switches. So in this case, if you have peering between the VPC switches, what will happen is the route will be still learned via the peer link. So if you have 100 VLANs, we don't recommend to have peerings across 100 VLANs. One VLAN would be sufficient to know the routing information to exchange the routing tables. And that VLAN, we call it as a transit VLAN. So if you have one VLAN with the route peering established between the two VPC peer switches, and even though if your uplinks fail, you will still be able to reach the core via the VPC peer link. So hybrid topology. In a hybrid topology, you can have a VPC connected devices and your STP attached devices. So typically the devices which you can't form a port channel, or you just want to singly attach to the VPC domain, those are termed as STP attached devices. So if you have a mix of VPC devices and STP attached devices in your domain, and you're using peer switch, then you hit upon a problem here. The requirement of having a peer switch is both the configuration across the VPC peers have to be consistent. That means you have to have similar VLAN priorities across both the VPC peer switches. With the VPC domain, from the VPC switch perspective, it doesn't matter because for them it looks like both the VPC peer switches look like a single STP route. But from the STP attached switches, STP attached devices, what happens is it can't do load balancing because the priority is the same. So essentially, one of the links will be blocked for all the VLANs. To overcome this situation, we have introduced a command called spanning tree pseudo information. So it has two benefits, or two roles I should say, when we enable spanning tree pseudo information. One is you can have different VLAN priorities by using this command. So you can have different designated priorities across the VPC peer switch. The other thing is, if suppose if your VPC primary reloads, and your peer switch will come into play only when the VPC is up, and if you have an STP attached devices which have a better MAC in terms of STP, so there's a possibility of the route getting formed over the STP devices. So we don't want to run in this scenario. So for that case, we can have a designated priority to ensure that always the route is in the VPC domain. So we have almost all devices connecting with VPC in a typical layer 2 domain. So what is the best practice associated when we have to connect an ASA cluster? So essentially with the ASA cluster, we have two sets of links. One is the cluster control link. So you have n number of devices and you can have n number of redundancy within a ASA cluster. So all the clusters are tied together by cluster control link. So if the cluster control link fails, the particular cluster member is brought down. So what we suggest, the best practice while using VPC to connect the ASA cluster is to use a unique VPC per ASA device. So if you have 5 ASA devices in a cluster, you have to use 5 VPCs. But for the data links where the data is exchanged, we recommend to have a spanned Ethernet channel and use a single VPC for all the data links from the ASA devices. And we need to leverage peer switch to make sure make sure the VPC switches appear as a single STP route from the ASA cluster's point of view. Coming to FEX or Nexus 2000. So Nexus 2000, this particular topology is Nexus 2000 connected in a straight through mode. That is, in this topology, FEX 100 is connected to switch S1 and FEX 101 is connected to switch S2. And we have a VPC between the server. So this is the recommended topology to be used. We'll talk about why it is recommended and how it compares with the other topologies when connecting to FEX. And this is the most widely deployed also, supported across all Nexus platforms. except for Nexus 3000. So Nexus 3000 does not support FEX. The other option is to have VPC or the FEX dual attached to two Nexus switches. In the previous example, we saw that the FEX has a single parent, or it's connected to a single switch. In this case, we are connecting the FEX to two switches, two different switches in the VPC domain. You may ask here, this looks more of a robust kind of a topology, wherein I have an extra layer of redundancy. My FEX is connected to two switches. This should be the recommended design. But it has some implications. It has some scale implications. So if you have this kind of topology, the total number of FEX which you can support and the total number of VPCs which you can support goes down by a significant amount. So we recommend, so if you have lots of dual NIC servers and the servers without a port channel capability, and you're okay with trading off with the scale limitations, then you can go ahead with the topology. If this was not enough, then we have something called as enhanced VPC. So if you really want to build a robust network and you're not worried about the scale factor into account, then what you do is you have two VPCs at two layers. So one VPC between the FEX and the parent switches, and the other VPC from the server or the host perspective. So this is again a very robust design, and it can be used for all kinds of servers, whether it's dual NIC, single NIC, with port channel capability, without port channel capability. But again, the trade-off is the scale. So scale is again significantly reduced from the previous design we saw. So the first design, straight through mode, we can achieve the maximum scale. Then the scale is reduced in the second design, wherein we have a single layer of VPC between the FEX and the parent switches. And in this, the scale is again considerably reduced. So this topology will have the least number of scale. Do you have a question there? That means Nexus 7000? The enhanced VPC will not be supported. So the question is whether this topology would be supported by Nexus 7000 series. So the enhanced VPC will not be supported, but this topology would be supported from the next release, 7.2, which is targeted for sometime this month. Yes, please. Yeah, 7 case will support the dual homed fixes. Is a question there? Yeah. I'll just come there. Yeah. There's no mic. Yeah. Okay. I don't know the remote will. It doesn't work from here. Yeah, okay. Yeah.
It won't be supported on the Nexus.
Yeah. As of now, it is not planned for Nexus 7000.
What's the scale? What's the limitation? You're saying that the number of fexes and systems are going.
The number of VPCs will come down.
Is there any document that says how?
Yeah, we do have a scale limitations. It like almost drops by half.
Okay. And is there any roadmap talking about the next slide, whether it's going to ever be supported on the 7?
As of now, it's not planned because it may be supported in the future releases. Yeah. So the question is, do we have a plan to support Nexus enhanced VPC for Nexus 7000? As of now, there is no plan to support it. Okay. So one more new feature, which is, yeah, you have a question, please? Okay.
Those are fax ports, but you could do that if you wanted to put like a 5 cables in to increase your port count and run a dual-sided VPC.
Okay. You mean to, what I understand is Nexus 5000 in a back-to-back VPC.
Say it again?
In a back-to-back VPC. So typically the dual layer VPC is between 4 switches. But in the case of FEX is just a line card. It does not have any local switching capabilities as such. So we'll not be able to do that. Okay, so this is a new feature which is being added to the Nexus 7000 from the release 7.2. So essentially, even though we have only a single port or single link in a VPC, but we still configure it as a port channel. So you may have 1 or 2 more interfaces, but typically what we have seen is in a VPC there are 2 legs, and on just one leg we just added into port channel, because of which the total number of port channel goes down. So we have a limited set of port channels which can be supported on a system, and by using the port channel here for VPC, the scale goes down. So we have come up here with, we have come up here with something called as physical port VPC. So in physical port VPC, you can actually configure the VPC on the physical port itself, something as shown here. So it can be on your FEX interface, it can be directly attached. So instead of putting it in the port channel, you can directly have it on the physical interface. And this is also extend the support for FCOE and improve the scale. So as of now, we are looking at the 1,000 physical port channel VPCs we can support with this feature. Okay. Yes. Sorry. Yeah. As of now, we have qualified 1,000 physical port VPCs. So 7,000, and it also supported on the 5,000, 6,000 series switches. Sorry. Pardon, please. What's your question? You can do it in the show VPC, and then you can find out whether the interfaces come up. So VPC, it will show you whether the interface is up. Okay. So we have many options for data center interconnect. So VPC can be used as one of the options, but the recommended way to go is with OTV. But VPC can be used to connect 2 data centers. So if you have more than 2 data centers, then you have to look for alternative DCI technologies like OTV. And if you try to connect more than 2, the configuration becomes messy, and it is not recommended and not supported. So how do we do a DCI with VPC? So typically, in a DC, in a particular data center, you have 2 VPC domain. One VPC domain is your aggregation VPC domain, which is for your server connectivity, and the other VPC domain is for your data center interconnect. So you build a multi-layer VPC between the aggregation and the data center VPC. And similarly, if you see the mirror image of the other data center, you extend the back-to-back VPCs across the data centers. So you may ask that what is the scale, what is the distance limitations when you have a VPC or dark fiber? So this question comes up quite frequently. So VPC as such does not impose any distance limitations. The distance limitation is imposed by the fiber. So whatever the distance limitations imposed the fiber is significant rather than anything coming from VPC. So advantage of using VPC is very simple to configure, does not require any additional licenses. It comes in the base license. Talking over the disadvantages, you can connect only up to 2 data centers. If you have a third data center to connect, then you have to go with some other option. The second thing is we don't support layer 3 over VPC. So if you want peering, layer 3 peering across both the data centers, then you have to go with additional links. So if you have to use VPC as a data center interconnect, this is the best use case for VPC domain ID, which I was talking about, that in a contiguous L2 domain, you need to have different domain IDs. So if you're using VPC as a DCI, this is the best use case scenario. Also, BPDU filters should be enabled at the edges so that if there's some problem in one of the DC, it does not get propagated to the other DC. And of course, for layer 3 peering, we don't allow layer 3 peering over the DCI interconnect, the VPC DCI interconnect, and you need to have separate layer 3 links. Okay, coming to dynamic routing over VPC or L3 over VPC. Why we need L3 over VPC? So VPC is typically a layer 2 technology. It is, as we discussed in the initial part of the session, it is to connect access layers. So why do you want to have a layer 3 routing over VPC? We'll discuss 2 use cases here, the most deployed use cases. So the first use cases, which is majorly deployed across many of our customers, is firewall peering. So you have the firewalls connected via VPC, and you have to run peering across the firewalls over the VPC domain. Till now, it is not supported. So the recommended way is to have static routes. The other use case which we just talked about is data center interconnect. So 2 data centers peering over an orphan port, and you require the L3 peering across the data center interconnect. With the current support, this is also not possible. So many customers have requested this feature for one of these 2 use cases, and there are many other use cases when it comes to layer 3 VPC. So anyone still looking for that feature, layer 3 VPC over on Nexus 7000? Good. Some of you are looking for that feature. So the good news is that from the next release, for certain hardware and topologies, we'll be supporting layer 3 over VPC. So let's look at what are the designs, the typical designs, and the hardware which we can use. So the first case we discussed about the firewall peering. This is a typical use case wherein if you can have a firewall or router behind the VPC, you can use L3 over VPC here. Then you can also use it over the DCI, which we discussed just now. As of now, in the coming release, the support is only planned for F2E cards and F3 cards. Yes, please. No, as of now, that's not supported. But we do have a like layer 3 or VPC plus is supported. We'll discuss later about that. Okay. So these are the 2 designs which are supported, and the support as of now is planned for F2 and F2E cards. Important thing to note about this is layer 3 or VPC is not supported across any of the Nexus platform. The only exception is ACI. So if you are using 9000 series of switches with ACI, in the ACI fabric, layer 3 or VPC supported. So there are some differences when we talk about traditional VPC and ACI VPC. We'll discuss towards the end of the session today. So the other designs which can be supported are the orphan port scenario or the STP attached devices. And in case if you don't have that hardware or you are not on that supported release in the interim, what we recommend is to use dedicated L3 links, or the other option, is to have a static route configured. Okay. Moving on, VPC and multicast. So PIM SSM is supported over VPC. As I mentioned earlier, how CFS or the Cisco Fabric Services syncs the ARP tables, does the configuration consistency check. It also syncs the IGMP entries across the VPC peers. So for in this example, if a receiver in the VPC domain sends a star.g entry towards the switches, and suppose due to the port channel hash, it lands on, for example, say switch S2. As soon as the switch S2 receives the star.g entry, it actually sends the star.g entry to the switch S1. So that both the switches will have the same star.g entries in the VPC domain. Then we have actually optimized the way how the syncing is done by something called as VPC incremental updates, wherein we do a batch processing just to increase the overall bandwidth utilization of the peer link. The next important thing is, if you have your source, if you have the multicast source in your VPC domain, both the VPC switches will act as active forwarders. Both of them can forward traffic. But what if you have your source in the L3 cloud, or if you have the source outside your VPC domain? In that case, one of the VPC switches will be elected as your active forwarder. So how is the active forwarder elected? It again depends upon the metric, the routing metric. And if the metrics are equal, which is typically the case in a VPC network, the VPC primary is selected as the active forwarder. Okay. So we just wrap up this section and we discuss what are the design options, what are the hardware mix and match we can use across the Nexus platforms, what are the limitations perspective of using dynamic routing over VPC, what will be supported in the newer release for Nexus 7000, and finally towards the end we saw how multicast can be used in a VPC domain. So we are well on track to achieve a goal, which is getting VPC right at the very first time. So let's start with the next section, VPC operations and upgrade. In this section, we'll talk about the new features which are being enabled to help overall network resiliency. So these all features have been requested by customers. So all these all the best practices are usually developed from you all people. So you all say, okay, I have this problem, and give me a solution to overcome this problem. So there's something called as self-isolation. So you may recall how we discussed what are the implications of using object tracking. So object tracking is more of a natural, more of a manual kind of a job. You track those links which are significant, and object tracking will kick in, and it will restore the connectivity, like the VPC roles will be swapped. So what happens with VPC self-isolation? Similar concept, better optimized, more kind of an automatic way. So similar case which we discussed for a financial customer where all the modules have failed. All the modules have failed on the VPC primary, the VPC secondary has shut its legs, the system, the traffic is completely black holed. if we haven't configured object tracking, it stays that way. But in the Nexus 7000 series of switches, starting from release 7.2, we have added this feature about VPC self-isolation. So in case of self-isolation, what it does is, there are various use cases and the various failure mechanisms already built in. So if all the modules fail on the VPC primary, it will just resign as being the VPC primary. It will just say, I'm done, my modules have failed, I'm just resigning from being a VPC primary. And it will advertise its isolated state over the VPC pair keep alive link to the VPC secondary. The VPC secondary will receive the isolation message from the VPC primary and say, okay, let me assume the role of VPC primary and I will start forwarding traffic. So this is one of the use case wherein all the modules fail. The other use case is the VLANs. So in some cases we have seen there, some of the customers typically reported an issue wherein no VLANs were getting forwarded on the peer link. From that perspective, since all the VLANs were down, the traffic was not getting forwarded across the VPC secondary also. In that case too, the VPC self-isolation will kick in and will ensure that the secondary takes over the role of primary and start forwarding traffic. And over upon that, you can as well have some triggers which you can manually configure in addition to the already built-in failure scenarios considered in self-isolation. So you may ask that what happens to object tracking? So the plan is once this self-isolation comes in, probably we can do away with object tracking, because object tracking is more kind of a manual configuration, whereas self-isolation is kind of an automatic. So many of our customers, so some customers who really like ISSU, and some of them, they don't like ISSU. They say, okay, I can take some traffic impact, but I don't want to do ISSU for various reasons. There's a myth, some others experiences, they don't want to do ISSU. For them, and the other reason could also be the shorter maintenance windows. They just want to remove one of the VPC pair switches and without affecting the maintenance window, because ISSU takes time and it has to be completed in that particular maintenance window. So they wanted a CLI wherein after executing the CLI, the VPC switch can be removed from the VPC domain. So with VPC shutdown feature, with a single CLI, we can remove the VPC peer switch from the VPC domain. So it's more like a manual configuration. In self-isolation, it was automatic, wherein the peer isolates itself. With VPC shutdown, you just hit VPC shutdown on one of the peer switches. It is out of the VPC domain with minimal traffic impact. And reintroduction of the VPC switch into the domain is again a CLI, single CLI with a no shutdown command. So you just do a no shutdown and minimal traffic impact, it is up and running. So typically, if you don't have this feature, then you have to follow a particular sequence of events. So a major financial customer in India, they followed a particular sequence of bringing, manually bringing one of the VPC pair switches down, but they didn't follow the sequence, they goofed up on the sequence. So that manual procedure is prone to errors. But with VPC shutdown, you can just remove it from the VPC domain. So this was not enough, and VPC shutdown just removes it from the VPC domain. What if I want to isolate the switch completely from the network, from the VPC perspective, from the L3 perspective, from all angles? In that case, we are coming up with a new feature in 7.2, which is graceful insertion and removal. With a single CLI, what we can do is we can isolate the box. Sorry, okay, sorry, I was not at the slide. Okay, graceful insertion and removal. So with the single CLI, we can isolate the feature, we can isolate the switch, and all my traffic can be can be paired across the other switch. To reintroduce the switch back into the domain, it is again the single CLI which is turning into a normal mode, and by using that it will be restored back into the network connectivity. So this is not only from VPC domain, it is from a L3 uplinks perspective also. Okay. But the underlying infrastructure, so system mode, maintenance mode is still using the VPC shutdown in the profiles. So you can tweak the profile as per your requirements. So these are the initial support for features in the graceful insertion and removal, or GIR as you call it, and the release wherein they are expected to be supported. So the in excess 5,000 or 6,000 series of switches we already supported. Yes, please.
So when you say support of 7x, or you mean the 77 at the
7,700
7,000?
as well as 7,000.
So that, yes, the 7,000?
Yes, yes, for 7,000, yeah. That's correct, yeah. From release 7.2. Okay. Okay. So the traditional ISSU and ISDD with VPC. So typically, if you want a hitless upgrade, ISSU is the way to go. And as I mentioned, some of the customers really love ISSU. So ISSU is a sequential event. So if you're doing ISSU on one VPC pair, the configuration on the other VPC pair gets locked. So you have to do on one VPC pair followed by ISSU on the second VPC pair. So let's look at how the newer technologies, how Fabric Path, VXLAN, and ACI are leveraging VPC. So what is Fabric Path? So with STP, what we are doing is we are avoiding STP. With VPC, what we are doing is we are avoiding loops, or we are avoiding STP. But with Fabric Path, we are completely eliminating spanning tree. And I can build a network topology. I can make any number of connections without being bothered about where do I place the STP route, and without calculating which links has to be forwarding and which links could be blocking, or how if I want to achieve load balancing, it will be more like a manual method. So in Fabric Path, it's a completely arbitrary topology. I can connect as I want. All the links are forwarding, and it is using the layer 3 ECMP in the underlay. So the configuration of Fabric Path is very simple. It is simply 4 commands to enable Fabric Path and get it working. So how do you connect? How do you connect the servers, the switches which don't talk Fabric Path? It is done through VPC plus. So you may ask me, what is the difference between VPC and VPC plus? Physical connection, they are all the same. Functionality wise, also they are all the same. The major difference here is in the peer link, in VPC the peer link is a normal port channel, whereas the peer link in VPC plus is a Fabric Path core port. So that's the basic, that's the only difference between VPC and VPC plus. And coming to your question, we support L3 over VPC or the Nexus 5000, 6000 series of switches. Okay, some problem there. Okay. VPC with FCOE. As you may know, FCOE is FC inside an Ethernet frame, FC frame inside an Ethernet frame. There is a lot of enhancement done to support this, because typically the fiber channel is very sensitive to losses. So it's a lossless traffic, and Ethernet is a lossy kind of technology. So there's a lot of enhancements has to be done to support FCOE. So in FCOE case, we support FCOE or VPC. So, if operationally speaking, you can't have FCOE or VPC, but what you can do is VPC and FCOE can run side by side on the same physical infrastructure, like the first hop connectivity from the host to the VPC domain is the same. So, although the port channel is different, you can have a different set of VLANs. So, you may ask that I am having VLAN 20 on one side and VLAN 30 on the other side. This may lead to a type 1 consistency, type 2 consistency mismatch in VPC. But when we are running FCOE, the switches in the VPC domain are aware that we are running FCOE, and they will be able to, they will not raise a flag for consistency check. So, in this case, my VLAN 20 can be mapped to my vSAN 20 and VLAN 30 can be mapped to vSAN 30. So, it's your converged network adapter will typically have 2 ports. So, one port is connected to one switch and the other port is connected to the other switch, and you are running FCOE and the LAN VPC in side by side topology. So, the FCOE VLANs are not advertised over the peer link. Okay. So, VXLAN, why do you need VXLAN? So, with the advent of virtualization, everyone is going for a VM nowadays in data centers, and you can have n number of VMs. So, most of the organizations have maxed out the number of VLANs we can support. So, typically in a standard VLAN frame, in a .1Q frame, we have 12 bits. With 12 bits, we can do as much as 4096 VLANs. So, that works out to like 4000 VLANs we can support from the normal .1Q frame. But using VXLAN, in VXLAN what we have done is we have identified the L2 segments and we have given 24 bit of space. So, with that you can have around 16 million of layer 2 segments logically. So, the other benefit is VXLAN is your MAC in UDP encapsulation. So, you can route your L2 segments over your L3 infrastructure. We will talk about how this is done. And so, there are two, if you see, there are two benefits of using VXLAN. One is you get a higher number of layer 2 segments, and the other is you can route your layer 2 packets over your layer 3 infrastructure. So, let us look at the packet format. Specifically, the one important thing to note about is the VXLAN header. And if you see the VNID, which is used to identify the layer 2 segments, is a 24 bit, and with that you can go up to 16 million of layer 2 segments. And as I mentioned, it is encapsulated in a UDP header, and it is transported over the layer 3 infrastructure. The MTU would be copied from the layer 2 header to the outer MAC. So, if you see there is a outer MAC. Okay, there should be some concept of fragmented, and probably I'm not that aware. I can't recollect at the top of my mind, but yeah. Okay. So, let's look at what is a VXLAN terminology. So, in VXLAN, typically we can say it is a layer 2 tunnel over the layer 3 infrastructure. So, we have something called as VTEPs, which is a virtual tunnel endpoints. So, it just identifies your tunnel endpoints VTEP. So, you just, and VTEP is essentially used to encapsulate and decapsulate your VXLAN frame. So, just add the header on one VTEP, and on the other end you can de-encapsulate the VXLAN header. So, we support VPC with VXLAN. So VPC is used by almost all technologies. Why VPC is used here is to have redundancy between VTEPs. So my host can be connected to a VTEP using VPC. And how the VTEPs are identified in the domain, since in VPC both the VPC peer switches have to look like a single switch. So how the VPC domains are identified is by something called as Anycast IP. So with both the switches will have the same Anycast IP, and it will identify it in the VPC domain with the Anycast IP. So one VPC domain is identified with the Anycast IP. It is recommended to turn on the peer gateway feature, and also like FCOE, the VXLAN header is not carried over the VPC peer link. So this is the typical configuration which we see. If you see in this case, we have two loopback addresses. So one loopback address is used for your routing protocol traffic, and the other one, which is the same across both the VPC switches, is your Anycast IP. So by this Anycast IP, your entire VPC VTEP domain has been identified. And then we configure a tunnel, which is the NV interface, the actual tunnel which starts from the VTEP. So how does a host 1 in a particular VTEP domain communicates with host 2 in the other VPC domain? So if host 1 wants to send a packet, it will source from, suppose if the VTP on the VTEP, the Anycast IP on the left hand is X and on the right hand is Y, and host 1 wants to send data to host 2. So it will source the packets with the IP as X. The Anycast IP configured on the VTEP domain is X. So it will source with the IP X, and the destination would be the IP Y. So the VTEP domain will encapsulate and decapsulate the frame, and it will be carried over the L3 infrastructure with the source as X and the destination as Y. So the switch, the host sitting behind the VTEP does not know it is transparent to its operation. So everyone is talking about ACI, Nexus 1000 these days. So I thought I'll also include something related to Nexus 9000 and ACI. So what is ACI? Essentially, ACI is Nexus 9000, which is your physical hardware, and the EPIC controller. EPIC controller is your application programmable infrastructure controller. So it is your policy engine or the configuration engine. So it is used for your policy configuration, and we always say that ACI is application centric. It is useful for application. So that is only one part of it. Yes, ACI is application centric. It is significant from an application perspective, but that is not the only part. My policy engine, my EPIC controller can also be used for software upgrades, can also be used to add a syslog server. So it's not the only point there. So it does much more. It does everything. So what are the differences when we compare a traditional VPC and the VPC in ACI? So if you see in this case, there is no peer link. The ACI fabric does the job of the peer link. So the fabric is rich, and both the switches, both the VPC peers will have connectivity via the peer link. The other interesting part is the peer keep alive link. So there is no peer keep alive link also, which is interesting. How will the peers, VPC peers will talk about it. So it is used by the role of the peer link is done by ISIS. So ISIS is running in the ACI fabric control plane, And with ISIS, the other peer, the VPC peer knows that a VPC peer is trying to establish a VPC domain. So how it is done is, ISIS will send the information to Europe, which is the unicast routing information base. The VPC manager will be constantly talking with the Europe, and it takes an update from the Europe, and it sees that, okay, I have a route to that particular VPC peer which wants to form a VPC relationship, and they start talking over the ACI fabric. So that's the major difference when you compare the traditional VPC with the VPC in ACI fabric. So all the limitations of VPC, wherein we don't support L3 routing over VPC, is overcome by using this approach. So you may ask that we are running CFS or Cisco Fabric Services over VPC. How do we do that? Because the two switches have to be presented to act like a single switch. How does the two switches act like a single switch? So we are not using CFS here. We are using something called as ZMQ, or the zero message queue. It's an open source protocol wherein we establish a TCP socket. It is pretty much similar how TCP works. So we have a sync and ACK, and that's how we establish the communication between the VPC peers. And all my CFS functions, like the ARP synchronization, the multicast synchronization, is done via ZMQ. The other important thing is, what is the failure scenario? So the ACI fabric is very rich. There will be n number of connections. But in a very rare case, what if the peers don't talk to each other? Then the VPC peer will safely assume that its peer has crashed out, and it no longer, it will assume the role of VPC primary. And since ACI fabric, the underlay, it's using VXLAN based terminology. So the same concepts of VTEP applies here in ACI fabric. So the underlying technology used by ACI is the VXLAN. So scalability. So the latest scalability numbers can be found at this site. So we keep on updating the scalability numbers, and some reference material to look after, to talk about these technologies. So what are the key takeaways from this session? We discussed why VPC is relevant in 2015. So we saw how new technologies like VXLAN, ACI, and Fabric Path use VPC, still leverage VPC. Then we talk about what are the VPC benefits. There are no block ports, how STP, how the limitation of STP is overcome by VPC. Then we talk about Fabric Path. So VPC was just avoiding STP, but Fabric Path is eliminating VPC. We saw how VPC, what is VXLAN, what is the need of VXLAN, how VPC works in conjunction with VXLAN. Then we looked at the ACI and how VPC is still leveraged in the ACI world. We also looked at how VPC integrates FCOE. So there's a favorite speaker contest. I encourage you to take up that contest, and please complete the survey. So your feedback is really important in building up the content for this session. And you are encouraged to attend other MT meetings, other sessions, related sessions which I've put up in the slides. I hope this session was informative, and thank you all for coming today. Thanks so much.